This lesson is on the second part of triangle congruence, which encompasses the ASA theorem and the AAS theorem. The ASA theorem, it stands for angle side angle. It says that when two angles and their included side, the side that's in between the two angles, in one triangle, are congruent to two angles and their included side, then you can prove that the two triangles are congruent. So in order to do that, we have to find two angles and a side in each triangle that are congruent. Notice that there's a circled piece right here. These arrows on lines, the arrows mean that the lines are parallel. So from previous lessons, we know that parallel lines cut by transversals create congruent angles. The angles in this case that would be congruent are angle A and angle E because they are alternate interior angles, and angle B and angle C are also alternate interior angles. So our first statement would be that our lines are parallel, that AC is parallel, that AC and BE are parallel, and that would have been given to us because it was in the picture that the arrows were there. Notice also that we have tick marks. So it is also given to us that AC is congruent to BE. From our parallel lines, we get our congruent angles. So we would say that angle A is congruent to angle E, and angle C is congruent to angle B. And our reason would be because they're alternate interior angles. That gives us three pieces of congruence. We're looking for three pieces. We have to make sure that the order is correct. We have to make sure that the side is included between the two angles. So to do that, we will look at in one triangle where our angles are that are congruent and make sure that the side that is congruent is in between those two angles. It is in between the two congruent angles, therefore angle side angle will work. And so we will write our congruent statement. Triangle ACD is congruent to triangle, and remember to use congruent corresponding parts. So A corresponds to E, so it should go first. C corresponds to B, so it should go second. And D corresponds to itself, so it would go third. That is how you prove that two triangles are congruent using angle side angle. A key thing to remember when you're looking at two triangles being congruent, from the last lesson, we looked at vertical angles, angles that make an X, we know those are congruent, and reflexive sides. So we know that if two triangles share a side, that we can say that the side is equal to itself using reflexive property. Today we're adding parallel lines to that list. When you see you have parallel lines, you should automatically remember that that will give you alternate interior angles. The last theorem that we're going to work with today is called angle side. Notice that the same pieces are congruent as in the third one here, but instead of the side being in between the two angles, in this case the side can't be between the two angles. It has to be the two angles and then one of the other sides. They're called the non-included sides. So if you'll notice, I actually give you all three congruent pieces here. Notice where the side is in comparison to the two angles in the triangle. The side is not directly in between the two angles, but instead outside of the two congruent angles. That's what allows you to use angle side instead of angle side angle. So we write our congruent pieces. This one is mostly given to us. Angle A is congruent to angle E. That was given. Angle B is congruent to angle G. That was given. And the last piece that was given was BC is congruent to GF. And since it's two angles and the non-included side, our reason is angle side, and we would write our congruent statement. Triangle ABC is congruent to triangle, match up your corresponding parts, EGF. There are two that don't work. After the last two lessons, we know that the ways to prove that two triangles are congruent are using side, 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 angle, angle, and angle, angle, side. Kids want to try and use angle, angle, angle. That one does not work. That one shows that the triangles are similar, meaning they're the same shape, but not necessarily the same size. The reason would be, if you're looking at a triangle like this, notice the angles are 50, 60, and 70, but if I stretch this out, the angles are still 50, 60, and 70, but this triangle is clearly not congruent to the original. It shows that they are the same shape, but they do not have to be the same size if all you know is the angles are congruent. The other one that does not work is side, side, angle, and that's because what is congruent is two sides and an angle that's not included between them. They're non-included angle, so it would either be this one or this one. And if it's this angle that's congruent, there's nothing that's going to relate this angle or this side, so it acts as a hinge. These two sides could be very close to each other, and this angle could be small and this side could be small, or this line could flip out this way, and then this angle would be very large and this side would be very large. These two would stay congruent either way. The SSA theorem does not work because there is no restrictions between this angle and this side. So this angle can be big, allowing the side to be big, or the angle can be small, allowing the side to be small. So these are the four that work. These are two that do not work. Do not use those as reasons why triangles are congruent. That concludes this lesson. The homework assignment for this lesson is worksheet 4.3, regardless of what geometry class you are in. Have a good day.